समीर इस मीटिंग के बाद मेरे से बात करो. I will answer right number the number. Yes sir. बड़ा sad आ रहा है. इसको आज already sent him a message. मुझे लगता है ये आखिरी वाला होगा सबको.
Mana net ya. Fine. So thank you, sir. Yeah. So today we are going to see a very important data set, which is part of the a book called Applied Predictive Modeling, or sorry, a package called Applied Predictive Modeling. And this is a widely used, I would say, package, especially we are working on manufacturing things. Okay, so let's see some of the data set, and I have taken here one of the data set, chemical manufacturing data, okay, which is part of this applied predictive modeling. Hope it will be interesting for everyone. It was interesting. I've also explored it for last 2-3 days, and I felt like it is more interesting and it is very relevant to manufacturing. So can I have a thumbs up? Is my audio clear?
Yes sir, fine. Audio, video, both are fine.
Perfect. Okay. Thank you so much. Thank you. Okay, so let's dive into this particular data. So what I have done is I have just imported this particular data into the Power BI so that we can show the visualization of that, and probably we can also see or export the data in R. Okay. So this is some kind of a pharmaceutical company. That is what we understand. Let's see from the help file if we have some information about the data set. Okay, so this is the chemical manufacturing data. I'm just copying and pasting in the help file to understand how this data is, what is this data is. Let's see if we, oh no, sorry, here. Yeah. So you can see here, this is the chemical manufacturing process data, and this data set contains information about the chemical manufacturing process, in which the goal is to understand the relationship between the manufacturing process, probably the critical to quality in each and every step, and the resulting final product yield. So there is an yield which comes out, and that is the final one. What should be our goal here? Can anyone give some pointers? Okay, so this data is having an yield, okay, from a chemical manufacturing process. So can you give some pointer? What should be the problem area, or what type of problem we will work on it? Can I have some interaction, please? Can you unmute and you can speak?
How the quality is affect, what are the parameters that affecting the quality production? That is a relationship.
Perfect, sir. Perfect. So that is the normally that would be the problem, or I would say like that would be the thing. But here we don't have the quality data actually. If you see, sir, we don't have the quality data. We have the yield, but obviously you are right. Yield is nothing but a good quality of a product which is coming outside. You are right. So with this particular data set, what they have only yield quality indicator, but again, it may be an like a wrong quality, or I would say like not up to the market quality was also used. That may also be a reason. Okay, no problem. But yield is here. So with respect to yield, what is that we have to think of? So we will always think of, I think, to maximize the yield. That means reduce quality. so that the yield is getting maximized. And in some processes, as you rightly said, there will be some rejections during the manufacturing process. So that also could be one of the problem area what we have to take in these kind of data sets. And this is, I think, a typical requirement in any of the I would say, like industrial problem. I think majority of the industrial problem talks about this. Say you have a cement plant and we have to target like how the cement plant quality is more. So that is what we will. Just a minute. I am getting some noise. Just a minute. Yeah. Okay. Fine. So let's understand. Now there are some raw materials which is there, okay, which is getting fed, okay. So raw materials in this process is put through a sequence of 27 manufacturing processes, okay, 27 manufacturing process, and from each of the manufacturing process we are having some result, okay, to generate the final pharmaceutical product, okay. The starting material is generated from a biological unit, okay. So there is a biological unit and there's some kind of biological reaction, and with that whatever is the enzymes or whatever is getting generated, that is being used here, okay, and has a range of quality characteristics. So this biological raw materials which are going inside are having some quality data also. So this is the input raw material quality data, and there are some characteristics for it. That also, see here they have sanitized it. They have told like, okay, this is the material available, and they have given a number for it, which will define what is the quality and what is the characteristics. The objective in this project was to develop a model to predict the percentage yield of the manufacturing process. So this data set, primarily it was given to see how we can predict the yield if we know like this is the type of raw material we are going to feed, and this is the process parameter what we are having. But if you see in a typical requirement, what will happen is, see, one of the thing what we don't have control is say the quality of the raw material. That will have variance. In practical scenario, it will have variance. So what will be there in our control is how the manufacturing capability we can improve, so that our critical to quality parameters we can maintain between a level. So again, like how we discussed about the last data set, which is on solar power plant. This is an industrial plant, and in this industrial manufacturing plant, straight away, if you improve the yield, what will happen to the energy consumption, sir? Any idea on that? If you increase the yield, what will happen to the energy or the specific energy consumption?
The specific energy consumption should come down.
Come down. Great.
Yeah,
great.
because there will be fixed energy consumption. So fixed
Yes.
energy consumption divided by higher production yield is higher production, then the production norm specific consumption has to come down.
Wonderful, sir. Wonderful, wonderful. So that's perfectly coined by sir. Like this will what will happen. So see, in terms of energy analytics, especially in the growing world, especially when people are talking about Industry 4.0, they want to reduce energy. Okay, and this energy reduction cannot only happen by say efficiency improvements in say compressor, in say a steam turbine or a boiler or something like that. Obviously, there are scopes, but those scopes will get saturated maybe in the first two iteration of the energy management effort. It will get saturated unless otherwise we put some big money into it, say and technological upgradation happens. A better efficient boiler or a highly efficient compressor if they are taking it. But where after that 2 or 3 iterations of energy management and low hanging fruits are harvested, the only way how you can improve your energy indicator in a typical industry is by optimizing your process, reducing the losses in your process, so that like how it was rightly pointed out by our colleague. This is the fundamental thing what we can do. Can I have some more response? Have you encountered this kind of situation in your plant? Can you give some examples like this?
So basically, thing is there is all the energy consuming devices. They have a fixed energy and variable energy. So if you try to improve the yield, uh, then that basically the fixed energy per unit per unit of production, that will come down. Variable energy will vary as per the production. So overall, the fixed energy, so energy should consumption should come down. Uh, that is the generally we have observed.
Thank you, Anand sir. Thank you. Any other views from other participants? See, I think we are hardly numbered in today's session. So let's have this more interactive so that we all mutually learn. Obviously, this is getting recorded and people will get used when the YouTube viewers are there. But our conversation only will add spices for those kind of things. So kindly share some experience like Anand sir have shared. Similarly, if I can have some response from other participants also, it will be nice. So do you think this kind of a problem area is there or you are facing in your daily life?
Hello.
Yes, sir.
Hello.
Yes, please.
Hello, I'm Manor Patil from Mumbai.
Hello, sir. Hello, sir.
Hello, I'm attending first time this meeting. So regarding this specific energy consumption, we are facing every month these problems we are facing because our production is a fluctuating. It is not a constant. Where the demand goes, production increase. Demand goes down, the production decrease. So there is a variation in the specific energy consumption. Specific energy consumption varies from 70% to 100%. And there is a minimum production or specific unit consumption is almost double. So we have the benchmark for the specific energy consumption. Suppose our production per month is 4,000 metric ton, then that will be the benchmark. That is our specific energy consumption. But production below that, then there is no scope of improvement or anything. So, irrespective of production, we are having the fixed energy consumption around 30%. 30% is the fixed energy consumption. So, it includes the HVAC system, lighting, and other critical equipment. So, that is the issue we are facing every month. Is that okay?
Perfect, sir. Perfect. But can we little focus on, say, in your industry? Obviously, your points are valid. Like there is a 30% of fixed part, and the variable part is with respect to what is the say the production demand. Okay, so based on that, you are producing it. But just imagine, like you have a steady demand. Okay, even in a steady demand situation, also, if we have to improve our energy indicator, what is the next important thing which we will touch? Do you think quality is a very important aspect which we will touch?
Hello, repeat again.
Okay. Our assumption is we are having a steady production.
Yes.
And we have an efficient fixed energy components. That is, our HVAC is optimized, our lighting is optimized, our compressors are optimized. So there is hardly very little scope in optimizing or reducing our fixed energy consumption. Okay, so in that particular scenario, what is the next thing you will touch?
Next thing, I will focus on the production area because that is the gray area where, because in our case, there are 5 to 6 different plants and our utilities are common. So even though 50% plants are off, utility cost is almost 70 to 80%. Okay.
Yeah.
So the focus area is the decentralization of the utilities. So on that we are working now. So it is a huge cost.
Wonderful, wonderful. Okay, so that is a major investment. Suppose if that major investment is not there, then probably I think you will be working along with your production department and see how the production process can be optimized so that the energy also can be reduced. Am I right, sir?
That's right. We are working with them because when we are going to take the shutdown, it is a 100% shutdown. You don't run the plant under part load. So you take the shutdown full day for 5 days, 6 days instead of staggering the shutdown. So that is our strategy.
Wonderful, wonderful. That is the production plan optimization. Okay, fine. So
Okay.
you say run fully at an optimum level or an a good energy efficient level, say for 15, 20 days. 10 days you can switch off the complete plant if you don't have a demand. So that is another way of doing it. Got it. So in this particular data set, if you see, this is a chemical manufacturing plant, and in this chemical manufacturing plant, we have data like what is the yield of this particular plant. That is how much good product this manufacturing process has produced, which can be sold to the outside world, and money can be, I would say, a revenue will be there for this particular plant. Okay, and they have given two sets of data. They have given the yield, and they have given the critical to quality parameters of their raw materials, and the process information, the critical to quality KPIs in their different processes. So there are some many manufacturing processes. You can see like 45 measurements of manufacturing process they have done, and there are some materials which are coming inside, biological materials. For that also they have given the characteristics. So with this particular characteristics, our problem with this particular data is how we can maximize the yield with a given quality of raw material. So we have a raw material, and that raw material is having that quality only. I don't think we can do something on that, because that is already bought and it is already there, and that is a variance which is not within our control. The next important parameter is the manufacturing process. Obviously, manufacturing process are done by your colleagues, your co-workers, and you can work along with them so that the manufacturing process, they can maintain the critical to quality parameter within a limit where more yield can be achieved. So this is the type of problem what we are going to touch. Do you think this kind of problem is also there in industry? Manohar sir, do you think these kind of problems is there in industry?
There are some problems, like the same
Wonderful.
problems we are facing.
Yeah, great. Okay, fine.
So,
I think
those are related to process, so we can't do anything, because that is not in our hand. Only we can ask them follow the certain things. Because in the production, chemical industry, production has the upper hand. So energy consumption is the secondary thing. So that is the
I but I understand this, but I think that is I would say like that is a status quo which we have to change. We have to educate our management. We have to appeal to our management. Like we have done the technological upgradation of all our fixed assets. More than this, it's not an economical. I would say there will be a balance, economical balance, which we can strike, and we cannot find a project which gives say less than 3 years payback. And we have to suggest to our management like there are other areas which we can concentrate, like why we should not have a Six Sigma methodology of how the process variance can be controlled, how the quality rejections can be controlled, and that also I would say the best plant are working on those kind of lines. I can cite some example. One of the example is say I think Green Business Center. I think everyone is aware of it. Am I right, sir? You know about this Green Business Center? This is a GBC. They call that. It is a part of IGBC. Okay, so this is the CII, Confederation of Indian Industry. This was when it was, I would say, started. It was donated by Godrej, so they have given the name of Mr. Godrej. But this is the GBC, and you can see in the GBC, they are now working not on say our fixed energy things. You can see they are working on how the cement formulas can be altered, how the process can be altered so that the efficiency from the cement industry can be improved. Okay, so how you can alter your production processes so that you get a good you get an efficient process, and thereby you can reduce your carbon footprint of your entire production process. So this is the latest, I would say, like it is there for some, at least for the last 5-6 years, it is very famous. And you can also go through this particular website and understand that this is the latest, I would say, like the paradigm shift what we have to have, because we cannot work on lighting, we cannot work on compressor for ages. You can work maybe for 1 year or 2 years, and if you get engaged with the good energy auditors, then they will easily plug those kind of gaps. But your process is very, very important, and for that particular process, you have to optimize it using the latest tools like data science and following a methodology like Six Sigma. And that is the very purpose why this particular webinar series IAEMP requested us to start, so that this awareness also is getting built with our energy management professionals. Okay, so on that particular behalf, we have researched, and thanks for the researchers from PSG College of Technology who helped us to find these kind of data sets and feeding us with a lot of examples. So now let's focus on, okay, before I forgot, I will post that particular link for you all. Okay, fine. So this data set contains information about the chemical manufacturing process, and in which the goal is to understand the relationship between the process and the resulting final product yield. Raw material in this process is put through a sequence of 27 steps. 27 manufacturing steps are there to generate the final pharmaceutical product. The starting material is generated from a biological unit and has a range of quality and characteristics. The objective is to develop a model to predict the percentage yield of the manufacturing process, given that this is the quality data of the raw material and the process steps. The data, there are 177 samples is given. And these samples can be found in any company from their historians or whatever records they are having from the quality department. And 177 samples of biological material, for which 57 characteristics were measured. So for all these particular raw material which is coming inside, 57 quality characteristics have been measured. Okay, of the 57 characteristics, there were 12 measurements of biological starting material and 45 measurements of the manufacturing process. Okay, so I will have something like 57 columns of data and one more column which is my yield. Okay. So the process variable includes measurements such as temperature, drying time, washing time, concentration of byproducts at various steps. Some of the process measurement can be controlled while others are observed. Okay. Predictors are continuous, count, categorical, some are correlated, and some contains missing values. Okay, so this is typically in any industry you will not get a perfect data set. Okay, so there will be some problems. So this data set is also having the same problem. Some of the problem is one is missing values. There will be some records which will be missing completely. So samples are not independent because a set of samples comes from the same batch of biological starting material. So they have kept mind like they're not confusing us more. So they are seeing like for one of the biological starting material, they have given the sample, so that that variance doesn't affect any of our problem. Okay, so this is the data, and this is coming from the applied predictive modeling package. You have to install this package in the R environment. After that, you can call this particular data set. Okay, so now I have just called this particular data, and I want to see what is the data set all about. Okay, like how we have seen all these manufacturing process data and other things are coming. So I think this is not giving a good visual for us. Let me put it something like this. Like I am asking the column names of each and every column in that particular data set. Let me maximize it and see. Okay, so the first column in the 177 is yield. Okay, and after that up to the 13th column, second to 13th column, we have the quality data of biological material. It can be something else we said. but this is the data what is being given. And after that, there are manufacturing processes, and from each of the manufacturing process, there are some critical to quality parameters they have given. So there are 45 manufacturing critical to quality parameters and 12 quality incoming quality or incoming raw material quality parameters are given, and this is the final in the process what is the yield they are getting. Okay, so this is the data what we are having. Now let's understand this particular data. So for understanding what I have done, I have exported the data into chemical data.csv as a file, and I have imported into the Power BI dashboard. Okay, so here what I'm seeing is I'm seeing like, okay, the 177 data sets are there. Okay, and I have plotting what is the yield. You can see the yield is varying between say some 27 till say 49. Okay, so this is the complete I would say the data set, and we are having from 27. Okay, and we are having a majority of the data between 38 to 44. 38 to 44 is the majority of the data we are getting it. Now, just to visualize it in a more statistical way, I'm just plotting it in a box plot. Okay, so this is the box plot, and you can see that 38 to 42 majority of the data are there, and there is an outlier. 49 is an outlier. That means it is not fitting with the 177 data. Not the yield which has come, I would say, beyond the normal data. Okay, something which we can eliminate also when we are doing the analysis. Okay, so now let's understand deep how this particular data is. So now first thing is say correlation. That means yield is a numerical value. So yield is a numerical value. That means it is a continuous number. Okay, and the other data or the columns is also a numerical value. So to understand better the relationship between two numerical values, there are many methods, and one of the method is seeing the correlation. When this is increasing, what is happening to the other thing, whether we are having a direct correlation or the indirect correlation. Okay, for that I am calling this particular library core plot, and I'm creating a correlation matrix. So the correlation matrix can be done by calling this particular function COR. Within bracket, I am feeding all the data inside. Let's see what will happen, because I know like the number of columns are very high, but let's feed the data and see what will happen. Okay, so now if you see, you are having 58 columns, right? So on 58 columns, I'm just feeding it inside and creating the correlation matrix. Now let me open this particular correlation matrix and visualize it. You can see here, this correlation matrix will be something like this. So it will have like yield to yield. Obviously, these both are same column, so the correlation will be 1. Now, next is yield to biological material 1, biological material 2, biological material 3. Like that, you have a lot of correlation numbers. Okay. Again, as we are having more number of numbers here, we will not be able to digest it properly, but we can see it in a more numerical way, or in a, I would say, a more pictorial way when we plot it. Oh God, when I plot it also, I think this is becoming very messy. So what I will do is I will split the data into two halves. One is I will see what happens with the yield with respect to the quality data, that is the biological materials what is coming inside. There are some parameters which has been given, and characteristics of that particular material is given. First I will relate how my yield is getting varied with respect to the characteristics of the biological material what I am feeding inside the pharmaceutical process. Okay, so now I am creating a core plot of it. Okay, so this is the core plot, and you can see here it is giving a good visualization. Let's wait. I think it will also zoom in. No, it's not zooming in. Okay, fine. So let's see the yield. Let me concentrate only on this particular column. Okay. So the yield is positively correlated with the biological material 1, 2, 3, 4. That is like characteristics of this particular biological material, the top 4. And it is strongly correlating with 6 also. And it is strongly correlating with 8 also, and I will also say 11 and 12. But other places it is not strongly correlating, it is weakly correlating. So this color will get changed based on the number which is called as the correlation number. And in the core plot, you are having different variants. Let's see what all the variants available. The help menu, okay. COR or PLOD, okay, yeah. Okay, you can make that as circle, square. Those things are also possible, and you can also display their values. I don't recall how I have to do it. So I'm just going to the help menu and I'm seeing. Okay, this is also something I want to show you because if you are also able to do it similarly. So what I have to do is I have to call this particular method function, right? So let's search for the method. Okay, method can be circle, square, ellipse, a number, shade, color, and pipe. Okay, so I'm going to use the number here. Okay, let's use number. Method is equal to then quotes number. Let's understand how it is. So now it's perfect. So I have numbers here. So you can see it is 0.36. So there is something like 36% is the correlation between the yield and the biological material 1. Like that 2, 3, 4, it is there, and 6 is also there. Okay, and 8 also there is a good correlation, more than 30. And we are also having 11 and 12, which is also having more than 30. So this is how we can visualize the correlation plot. Now another way of doing it is seeing the values. Okay, so I can see something like because the correlation is a data frame, like so it is a matrix. So I want to see only the first column of it. So what I will do is I will call like C within bracket open. I will leave the first space, or I would say I will start with the comma because I want all the rows, but I want only the first column. So one is the column row into matrix. So I want all the rows, so I'm not mentioning anything. And in the column, I want only the first column. So I'm asking it only to give the first column. So now it has given the first column, but again, you can see it is 0.35 and again it is 0.48 and there is something minus 0.11. So I want to sort it. Okay, so sort, typically if you apply this particular function sort, it will be something like this. So what is this? This is descending. It starts from the smallest one and then goes to the biggest one. So in order to not do it, I am saying it's decreasing is equal to 2. So now I am sorting it. That means I am sorting it from a ascending descending perspective. Okay, so descending perspective. So yield of the first one we have to eliminate it because it is the correlation between yield to yield. But the second one is very important for me. So biological material 2, 6, 3, 8, 4, 12, and 1 and 11. I would say like only these things are having some relationship with the yield. Okay, I will only pick these things. Others I may not pick it because it is having a very weak relationship with yield. Okay, so it can be with the limited data or the limited evidence what is given to us, we are making this particular conclusion. Okay, similarly, let's try for the remaining one, which is the manufacturing process. So how to do it? Very simple. Just copy this particular code. Okay, and paste it in the bottom. Now the first row to 13th, first column to 13th column, it is yield till manufacturing process. So now what I have to do is I have to take only the first column, and what are the rest other columns? It starts from 14, right? So I have to ask you give it till the end. Okay, so I'm just asking you give it completely this one. Okay. Now again here I am going to see the only the first column of it because that is what I am interested. Again the first column, let me sort it, but I don't want this, I want descending. Okay, now it is descendingly sorted. That means I have added not only the biological material, I also have added the manufacturing process data also. So now when I add the manufacturing process data, you can see the yield is having good relationship with the manufacturing process 32 critical to quality parameter. So the manufacturing process 32 is having a very good relationship with yield. When it goes high, it also increases the yield. So if it is 0.60, that is almost 61%, it is having a good correlation. So now we can also put a cutoff here. Okay, let me put a cutoff, like if it is more than 0.35, that means it is important for me. So now you see I have 58 different parameters, but for me, for the yield to get affected, how many parameters are very important for me? It is only say 1, 2, 3, 4, 5, okay, and 5. Yeah, that's all, 5. So almost 10 parameters are all only important for me. Other parameters are not needed. So how many parameters were originally there? There were almost 57 parameters originally there, but only the 10 parameters, top 10 parameters is giving me a good result. Now, I can also see this in a different way. Okay, how I can do? I can create a model, and there also I can do it. Let me create a model. Okay, so M1, let me call that model. Okay, model 1 is equal to LM. It is the linear regression. Okay, and yield is my important factor, right? So I'll just copy this particular thing because typographic errors will make a big problem. Okay, so I have asked yield. Okay, and I want rest other things, right? So I have to put the del symbol and I have to put dot. That's all. Okay, let's see if only these things are enough. Okay, just go to the help menu, type this particular LM command. Okay, and it will show you how to create an linear regression equation. Okay, so what other things I have to give? I have to give it the data also. To strike, you can go to the what is that example. Okay, so example, just go there. You can see here. It needs the data also to be given. Okay, so I have to give it the data. Now let's give it the data. What is my data? Data is equal to chemical process parameter. Okay, so this is my data. Let's see if it works. Yeah, it works. So I have my linear model, which is a linear regression model, which I have built, and it gives me a result. Okay, let's see what the result is. Okay, for seeing the result, what I have to do, I have to call the function summary. Okay, give me a summary, like how we will ask our subordinates, our juniors, same way, give me a summary, that's all. Then it will give you a summary. Let's explore the summary a little bit. Okay, first thing in the summary, it will be something like, it will give the formula. The formula is, I have taken yield and del dot, that means all the other columns other than yield, I have asked the model to take and predict what would be my yield. Okay, and this is the data set I am going to use. Okay, now there are some error. Okay, that means there will be an actual yield and there will be a calculated yield. The difference between the actual yield and the calculated yield is called residue. Okay, so that is a residual, and with this residual, what is that we can understand is the prediction is almost good. See, the minimum is minus 2.18 and the maximum is 2. That means this is almost like a 4. 4 is the error. Okay, absolute error, if you say, it is only 4%. Or I can say plus or minus 2%, I'll be able to predict the yield, what my process will get or deliver if I know what would be the raw material I'm going to feed and what would be the characteristics of the raw material what I'm going to feed, and if I know the critical to quality parameters of my chemical process. Okay, so this is a very important thing. And now just imagine if there is a new set of information, say there is a new material which has come inside, and that material, our say your production department wants to take a trial. So probably from the energy cell, you can request them, can you create a model with your historical data, and using that particular data, can you also predict what would be the yield you will get with the new material which you have sourced, where the characteristics of the new biological material is of some X or Y. Okay, what would be the yield? Okay, this is that yield going to improve or your yield is going to reduce? Okay, so like this, you can also work with your production department and help them to optimize their process, where collectively you can improve the energy indicator of your process. Okay, so this is the important aspect. Okay, another important aspect I want to point you out. The another important aspect, we have seen the correlation and we have found like a certain columns only is having the relationship with the yield. How to find it out? Okay, so that is another important aspect. So how to do it is, you can see something like there is a star which is available. You can see here. Okay, you can see manufacturing process 32 is having a very good relationship with yield. Manufacturing process 28 is also having a good. So that is how the R statistical tool will indicate you with the star. Okay, so this star comes with the p value, which is the probability value, which will give you whether this particular variable is having a correlation with the yield, and you will be able to get a good result. Okay, another important indicator what you can see is the R square value. You can see R square value is nothing but error, mean standard error squared. Okay, so as the error is between minus to plus, so you cannot if you want to have a I would say like absolute value, then what you have to do, you have to square it. Okay, you have to find the root and you have to square it. Only then you will be able to get an absolute value. That's why it's called MSC, mean root square value. Okay, and that value is 0.79. So I would say like 80% it is good. Okay, accurate. Typically you can have that particular attention. And there is something called adjusted R square. This is very similar to the saying, too many cooks will spoil the food. Okay, so that is like you cannot have too many variables into the model, then the model will get confused. Okay, so we have to feed only the best values, and we have to avoid something called covariance. Covariance is one of the parameter or one of the column is having a good variance or good correlation with another column. If you have those kind of variables, then it is better to add any one of it. You should not add both. Okay, I will explain you with one of the indicator here. Okay, fine. So this is what we have already seen, right? So I think the font size is not good, so I will just go to something else here. Yeah, we can use this. Okay, so you can see here, this is what we have already seen. Okay, now let's understand whether I should take biological material 2 or biological material 1. Okay, so for this, what I have to do is I have to see how my biological material 2 is correlating with biological material 1. You can see here biological material 2 and biological material 1 is having a strong correlation. That means if this is increasing, this is also increasing. Okay, probably this is for the same biological material, right? So say this is one indicator, say temperature of the biological material which has come inside the process. Second is viscosity. Okay, so we all know like, okay, temperature and viscosity has a good correlation. If temperature is high, obviously the viscosity will also reduce. Okay, but that is an inverse correlation, but I'm just saying. Okay, so if these two things are there, probably I have to select any one of it, and I have to select a variable which makes more sense for the process. Probably I will select, say, the viscosity, maybe if that is the important for the process, or that is what the operator can control. Or some places people will say, I cannot control the viscosity, but I have a chiller or I have some equipment which can alter the temperature. Then I will say I will leave viscosity and I will take temperature as one of the variable for predicting the yield. Okay, so this particular call you have to do in consultation with the subject matter expert or your process engineers, and because they only can tell you which particular parameter you can control. Okay, so now Now again, not too many variables. So there is one way of reducing it, that is called AAC function. Okay, so there is a library called mass. Okay, mass, okay. And I have just imported the library, and mass has something called AIC. See here, there is something called the step AIC. So what the step AIC means, okay? So let's ask our help file, okay? So this choose a model by AIC. AIC stands for Akakai Information Criteria. So this is an auto-tuning kind of a functionality, okay, which is being used widely, especially we are talking about numerical values. So I'll show you a demo of it, but you can see what it does. So if you are having some model and you want to understand which all the variables are going to affect the model. Okay, for example, you are having, say, there is a data set which is birth weight. Okay, and this birth weight, there is something called low or medium or good. Okay, and you have some other variables also, and you have asked all the columns to come inside, but you want to understand which particular column is having more weightage. Then what you can do is you can ask the step AAC function to eliminate certain variables and then give you a indicator whether that makes sense. Okay, so that is possible. So now let me use this particular step AAC function and feed the model M1. So what this model has, the model has yield and other 57 columns to predict the yield. Okay, so now with the mass library, I'm going to call this particular function, and you can see the magic. See, automatically it will start thinking of what are all the things to eliminate and what are all the things to keep. Okay, and it will suggest which is the best one to do. Okay, and you can see it also gives some information. Okay, let me zoom in. Okay, I'm just going high. Okay, because this is a cloud environment and it is very fast. Okay, normally if you compute it in your laptop, it will be very slow. See, first it started with the yield and it has put all the 57 variables inside, and it have calculated an AAC, Akakai Information Criterion, which is 64.75. Again, now the second step, what it has done is it have removed one of the variable. You can see here the variable is getting ended here. Now you can see that particular place is empty. Okay, so it will reduce it. Then also it will see, okay, the Akakai Information Criterion 64.75 stays. That means with that particular variable, I'm not having a good, I would say, like there is a value for that particular variable. So removing is not affecting my my model. Like that, it will start eliminating. You can see here, it will start eliminating. And finally, it will give one particular model which is good. Okay, and you can see here, it is giving something, a good model, which is having a good Akakai Information Criterion and with a limited number of variables. Okay, again, I'm having some error because there are some missing values in certain rows. Okay, so this is another pointer. That means I have values which are missing. Now I want to understand which are all the variables or which are all the columns which are having missing values and how to eliminate this particular missing values. Now just imagine if you have done this particular same thing just by calling the LM function, you will not know about this particular variables. In real-time case also, you will have hundreds of columns which will be given by your process team as data, and they will ask, like I say, one or two variables to predict. But you have to you cannot feed all the 100 variables inside. Then what will happen? It will be a mess, right? So what we have to do is we only have to identify certain variables, and those variables only have to be used. So that is the typical way how people will do it. Okay, that is why I introduced this particular important function, step AIC. So now let's put this particular variable model as a model 2. Okay, so now I have the model 2. Okay, if it is error, then it will automatically eliminate that particular formula. Okay, now let's see what my model 2 is giving me a result. Okay, oh. Okay, think there is a problem here. What is the problem? Step A, see, I think I'm mixing something. I have to give something called direction. Right? Yeah, direction is equal to both. Okay, and yeah, scale is equal to 0. Okay, I will also scale and direction also I will give. Okay, say scale. Let's go to the top so that we know that what is the syntax I have to use. Scale, yeah, 1, and direction is equal to both. See, okay. Number of rows in use has changed. Remove missing values. So I have some missing values in the model. So I have to remove that. First, let me understand how many missing values I have. Okay. So how to find it? There is a function called is.na. Okay. Sum of is.na in the data. Okay, so I have 106 missing values. So that is the problem I am getting. Now I want to understand where I'm having the missing values. Let's check if it is there between 1 to 13. Okay. Oh, it is not there. Now let's check 13 to 20. Yeah, 13 to 20, it is there. So there are some missing values in the other side. Okay, now let's put it something like this. I will use only 1 to 13, not others. Okay, so let's do it that way. So what I will do is I will just rename this M1 data between 1 to 13. Okay, and now again let me create the model. And now I'm not getting a good R square value, but just to demonstrate how the step AAC works, let me use this particular thing. Okay, so now I have removed the columns which are not having, I would say, missing values. Now let's recreate the M. Now you see, without error, I am getting it. Now, if you go deep into it, I have 12 different variables. Now you can see there is a plus sign and there is a minus sign. That means among the 12, it has only selected the top 4, okay, which is 10, 4, 11, 2, 0, 1. Okay, now let's go to our correlation, what we have done. Okay, and with this correlation, let's see whether we are getting the same thing here. Okay, so 10 is there somewhere. Where is 10? Yes. Where is 10? I'm not able to see 10. Yeah, 10. So 0.2 is giving my good result. Okay, so 0.2 correlation is giving me some good result. Now next is 4. 4, where it is 4? Yeah, 4 you see 0.37. Okay, and 11. Okay, where is my 11? Yeah, you see 0.35. Okay, now 2, it is 0.48. Obvious, we cannot leave this. And 1 is it is 1. Yeah, 0.35. What are the things it has eliminated? Let's see. 5 is eliminated by it. Yes, you see 5 is eliminated because it is having a weak correlation. 9 is eliminated. Yes, 9 is also eliminated. 7 is eliminated. Yes, 7 is also eliminated. Okay, so this is how you can also make a feature selection with respect to correlation as well as with these kind of functionalities like step AIC. Now we know like there is a new model which got created. Let's understand the new model and how the accuracy of this new model. So accuracy of the new model is 37. Okay, and what was the accuracy of my earlier model? It was 37.74 and 33.15. Okay, now my M1, you see 34.4. Now, very important things to keep in mind is now I'm able to predict the yield with less number of variables. I'm not using more variables. I'm using only less number of variables. In that way, it is giving me a good result. And you can see the plus sign, whatever have appeared, it is being added into the yield. Okay. So this is how we can do the feature reduction. So from 13, what we have done is we have reduced 1, 2, 3, 4, 5, 6, 7. So from 12 biological material characteristics, we have now come to only 3 plus 2, 5, 6, 7 materials. So other things we have left. Similarly, we can also do it for the manufacturing process CTQ. Probably you can also try in your home. Okay, and I am just putting this in the chat window so that you can make use of it. Okay. Okay, now the code is also available with you, and kindly use this particular rstudio.cloud. Okay, that also I'm giving to you. Kindly give a try. And next class, what we will do, we will try to digest not only the input raw material characteristics, we will also add the manufacturing process critical to quality parameters and see how the yield can be improved, especially without without having columns which are having NA. Okay, so we will eliminate those NA values and we will do the step AAC function. And from the linear regression, we will go to some complex models like say addition tree or a random forest kind of models, and we will see whether we will be able to predict the yield, and this will come handy whenever you are approaching a problem in a real-time manufacturing process, how to improve the energy efficiency of your process with the information what you can get from your quality department and from your control rooms on your process. Okay, thank you so much for your attention. If there are some questions, I will be happy to answer. Do you have any questions, sir?
Hello, sir.
Yes, sir.
Uday Shankar, sir. Sir, regarding how the energy analytics can be applied in college premises, can you explain on that?
Yeah. So, and your problem area in a college would be like you want to work on some research project, or you want to optimize your energy indicator of your college.
Yeah, I want to optimize the energy.
Okay.
For which I have to apply this energy analytics. So
Yeah.
how can I just need some ideas.
Okay. So first of all, I think you will be having some historical data of your energy consumption, and you will be having some energy meters for each and every block. So if those informations are available, then with that information, you will be able to first forecast how much should be the ideal energy consumption with number of occupancy. So probably you can mute your mic if it is noisy.
Oh yeah.
Okay. So for your college, if you are having each and every block, what is the energy that particular block is consuming, and you have the footprint in each and every block, that is the usage in your blocks, and you can estimate like, okay, whether the energy is being used for a value addition. If without a value addition, if the energy is wasted, obviously your energy bill will go high, and you will not be able to explain the increase in the energy consumption, because there will not be any occupancy, or without an occupancy, energy have gone high. So what we can do here is first with those variables, we have to identify which variable is contributing for your energy consumption with your historical data, like how many students were present, how many classes were conducted, how many indoor classes were there, how many outdoor classes were there, and with the time and date, we also can see if the weather nearest weather station, that weather data can also be used, because that determines whether you need light, whether you need fans. Okay, and with all those information, we can first coin down which are all the key important indicators or features which is determining the energy consumption of your entire building. Once you know about it, then you can either make some plan. If this is going to be my features which are deciding my energy indicators, you can probably work on it, how you can optimize it. Second is if you know, say in another 3 or 4 months, if you are going to have, this is the pattern of the number of people coming inside, then how much will be the ideal energy consumption based on your historical best performance, and that you can give it as a target to your facility department or your management department, and that will be an I would say a key performance indicator over which you can have your energy management program. So you can have the baselining forecasting, and after that baselining, and then you can coin down how you can improve on that particular baseline. Second, you can identify which particular parameter is affecting your key performance indicator. For example, lighting is affecting your key performance indicator. Probably you can think of how daylights can be efficiently used, or how a new technology of light which can give you increased lumens per watt can be selected. So like that you can have your program. So we have to start with data collection, then do what all the key important features affecting your final KPI, which is your energy consumption of your college, and then act on each and every variables.
Thank you, sir.
Thank you, sir. Yeah, Mr. Bharat Singh Yadav. Okay, so you want to understand what is that minus. Okay, see what this step AAC function does is it helps us to identify which are all the key values which we have to take into consideration, and which are all the values we can eliminate. Okay, so that is how it is putting as plus and minus. So whatever is key, that will be shown in the formula. You can see here yield del biological material 03 plus I have used, right? If you use minus, then it will automatically will not be there in your model itself. That means it is almost nullified. You will not use it. So that is how it is showing as plus and minus in this particular table. Probably I have given you the say code also. You can also try hands-on in this particular RStudio cloud. You don't have to install the software also. In the cloud itself, you can do this particular exercise. Experiment with it, and you will also find out. Please try. Otherwise, it will be only a learning. Please also try as a hands-on. And if you are having some problems during our next interaction, you can also ask me.
Thank you, sir.
Thank you. Thank you so much.
The participants were less. Today, I think we had an interactive session.
Yeah, I think everyone will accept this. I think we don't need many participants. What we need more is interaction. So if the interaction is there, that will make that particular class more live. Let's not focus more on getting the number of participants. Let's focus on getting quality participants, and let me have more interaction. And maybe I like this interaction to be much more. Like you can also have some data. Maybe if you want to use your college data, you can also share that data with us, or you can ask us what all the methods you can use that particular data, like Mr. Uday Shankar have asked. Similarly, kindly come with some problem area. Need not like you have to specify where this particular data is taken at all. So let me have a, I would say, very sanitized discussion here, and mutually we all will learn. Okay, thank you so much. Mr. Patil, you want to
Yeah. I have
Yes.
some question regarding specific energy consumption.
Yes, sir.
So, irrespective of production, the specific energy consumption varies with the season. Right? Is that okay?
So please come again. Irrespective of production.
Is irrespective of production, the specific energy consumption varies with the seasonal variation. So maybe monsoon season, winter season, and summer season. So because of that external parameters, specific energy consumption, there is a variation. It's not much,
Wonderful,
maybe
sir.
10%.
Wonderful. Yeah, actually, I would say I will treat this as an opportunity. For example, if you are having those kind of variation, probably you have to work on your installations. Probably you have to say if in summer you are having more HVAC. Okay, there are passive insulation methods. You can have some heat reflective coating. You can have some sunshade with some say there is a net called I think shade net. Okay, that is being used predominantly, and you have to understand because of this variation in temperature, what is that really is happening. Sometimes it will be not only the load of HVAC will get increased, sometimes it will be the efficiency of your HVAC equipments. If that is the case, then probably you have to work with your OEM and see like those variations should not affect the efficiency of your equipment, and you can reduce those variations. Then that variation will in turn will reduce your specific energy consumption variation.
I have some question regarding boiler, because during rainy season there is a more condensation of the steam. So